to which we compare data obtained today. And a horizontal horizontal line indicate sea levels from the same period. The point where these two axes intersect corresponds to the Earth's balanced state during the Holocene. Currently, we can see that the Earth, represented by a small sphere in the slide, is moving away from the balanced state. Near the point where the Earth is now located, its path splits into two possibilities: stabilized Earth and hothouse Earth. If the Earth follows the hothouse path, it could take millennia to return to its previous state, and life on the planet, on our planet, might become impossible. However, if the Earth follows the stabilized path, it would take hundreds of years to return to a balanced state. And now we can see that the climate change planetary boundary was transgressed because the threshold for this planetary boundary is set at 350 particles per million of carbon dioxide, or plus 1 watt per square meter for radiative forcing. And we can see that the current global value is 417 particles per million of carbon dioxide. And what consequences do we have due to climate change? And due to climate change, we have more intensify and more frequent extreme and climate weather and climate extreme events, such as droughts, wildfires, heat waves, and floods. And climate change results in melting ice, sea ice in Arctic and Antarctic, and sea level rising and loss of biodiversity. And all of these consequences lead to increase in economic losses and deaths. The figure presents data on death and economic losses caused by high impact weather and climate events from 2015 to 2018 across the 6 regions selected by World Meteorological Organizations. We can see that in Asia, Europe and Africa, mortality caused by weather and climate disasters exceeds the economic losses they induce. This is in the first place because heat wave are the deadliest weather events along with wildfires and their greatest economic losses were associated with weather extreme in North America. This is because the region is heavily impacted by tropical cyclones, which are always linked to the highest economic losses. This figure shows how key climate indicators are connected to the achievement of Sustainable Development Goals. The 7 indicators such as carbon dioxide concentration, ocean acidification, global temperatures, ocean heat, sea ice extent, glaciers, mass balance, and sea level rise pose serious risks to sustainable development. These climate changes affect biodiversity, which in turn threatens goals like food security. This is the goal, the second goal. Poverty reduction, this is the first goal, and peace, this is the 16th goal. For example, rising carbon dioxide level can harm ecosystems that provide us food, while melting glaciers and rising sea level can disrupt communities and ecosystems, making it harder to achieve these important global goals. And let's consider another planetary boundaries such as biosphere integrity. To understand this planetary boundary, we need to consider such concept as genetic diversity and functional biosphere integrity. Let's consider this concept. Genetic diversity refers to the variety of genetic differences within a species. In the image, you can see an example of genetic diversity in the food. All the apples shown in the picture belong to the same species. But we can see that these apples have very different colors, from green to purple. And variation in the alleles of the genes. Genetic diversity refers to the variety of genetic difference within a species. In the image you can see an example of genetic diversity in the apple. In the image, all the apples belong to the same species. Variations in the alleles of the genes controlling their color result in apples that are green, yellow, red, or even purple. Similarly, differences in the alleles that influence flavor make each type of apple this unique. And why is genetic diversity is important? Genetic diversity is important because it helps species adapt to changing environments. A higher genetic diversity makes species more resilient to changes like climate shifts, diseases, and other threats. If genetic diversity is lost, species may struggle to survive and could even face extinction. For instance, we will consider one example of loss of genetic diversity in such species as panther, in Florida panther. The Florida panther was saved from extinction by introducing new individuals to increase to genetic diversity. The Florida panther was once widespread with high genetic diversity, and in the image we can see the panther of different, very different color that represents genetic diversity and represents different alleles of genes. And hunting and habitat loss reduced population size of the Florida panther and resulted in very low genetic diversity and even in breeding. And 8 female panthers from Texas were moved to Florida to breed with Florida panthers. And this helped restore this species, and now we can say that thereby the genetic diversity was returned to the Florida panther. Functional integrity refers to the ability of a system to work effectively as a whole, with each part doing its job to support the overall function. Similarly, in natural ecosystems, functional integrity means that all species and processes like plants, animals, water cycles, and soil nutrients work together in balance to keep the ecosystems healthy and resilient. This is crucial because when the balance is disrupted, such as by population or habitat loss, it affects the entire ecosystem's ability to support life, including human life. In short, functional integrity is about keeping all parts of a system working well together so that the system remains healthy and effective. We have one example of the disbalance in natural ecosystems. In the mid-19th century, European rabbits were introduced to Australia. Without natural predators, the rabbits began to breed uncontrollably. However, when forests are cut down or land is used for farming or cities, some species disappear and others become less common. The biodiversity intact goes down. The current value for the extinction rate is at more than 100 extinctions per million species per year. This exceeds the planetary boundary in 10 times, by more than 10 times. For the biodiversity intactness index, only values above 90% are considered good. Any lower values indicate a decline in biosphere integrity. In the figures, species abundance is represented in figure A, and species reaches is represented in figure B. We see that the most of the territories have big losses in abundance and richness of species. This is all territories with the indicate more than 90%. Consider another planetary boundary, such as novel entities. This planetary boundary refers to human-made chemicals and materials, such as plastics, pesticides, and industrial chemicals. An increase in novel entities can lead to severe environmental problems, such as environmental pollution, disruption of ecosystems, loss of biodiversity, and potential health risks for human and wildlife, for humans and wildlife. And the one founder of the planetary boundary concept claims that there has been a 50-fold increase in the production of chemicals since 1950. This is projected to triple again by 2060. And it is clear that the threshold for the novel entities was transgressed. One of co-authors of the planetary boundary concept said that there has been a 50-fold increase in the production of chemicals since 1950. This is projected to triple again by 2050. And it should be noted that plastic production alone increased 79% between 2000 and 2015. Of course, the planetary boundary for novel entities was transgressed because the planetary boundary threshold for the novel entities is set at 0 because these materials and chemicals are artificial and they were not be presented in they were not be present in the pre-industrial period. And we will stop other last planetary boundaries. Land use changes can lead to deforestation, soil degradation, and loss of natural habitats. The planetary boundary for land use is set at more than 75% of original forest cover. And in the slide we can see that current global value is less than 62% of original forest cover. In order to see what terrible scale of land use changes and deforestation we have, let's see the video. This video demonstrates deforestation of the Amazon region in the period from 1975 to 2012. And we can see that the scale of deforestation is very hazardous. And now we come back to the planetary boundaries assessed in 2023, and we can see that currently Earth is beyond 6 of 9 planetary boundaries. In addition, ocean acidification is approaching its planetary boundary. We are approaching dangerous tipping points. We are facing the real risk of destabilizing the entire planet. All planetary boundaries are interconnected, with climate and biodiversity being the core influencing all others. And in this slide, we can see that since 2009, the number of transgressed planetary boundaries has increased, which is highly concerning. In 2009, 3 planetary boundaries were crossed out of the 7 assessed. By 2015, 4 planetary boundaries were crossed, and in 2023, 6 planetary boundaries have been transgressed out of the 9 assessed. And where are we now? Now we are living in the Anthropocene epoch, marked by rising trends in both socio-economic activities and Earth systems. Population growth, urbanizations, and telecommunications and so on are increasing, along with concerning trends like a higher carbon dioxide concentration, tropical forest loss, marine fish capture, and so on. And but we need a new perspective where these increasing trends are replaced with decreasing ones. It is possible for us. We have such possibilities. We have the tools, the knowledge, and the technology. If we cut emissions by half by 2030 and reach net zero by 2050, we can stabilize the planet. We must decarbonize energy, industry, transport, and agriculture, and protect our ocean and forests, which absorb much of our emissions. The next 10 years leading to 2030 must be the decade of the most profound transformation the world has ever seen. This is our mission. Thank you.